YouTube channel. So I'll try to do this after the class today. More second. Finish. Okay. So hopefully everybody got their files up and ready. We are on Mila, hit start. We created levels in the last class, and we discussed that a level is a work plane in a rectangular shape that hosts elements and allows to define what is the finished floor in a building structure. It also enables us to schedule and assign elements to different building floors. We also created grids, which are vertical work planes that enable us to align structural frame members to grid intersections. And we created this system of bays of grids in the X and Y. And we learned also how to change grid numbers by just clicking on it and changing the instance properties. We finished last class with the creation of a floor. A floor, it's a system family. And what that means is that it cannot be saved as an external file. It can only be copy paste between projects, but you cannot save it as an .rfa file because system families by definitions cannot be saved or exported as individual files. And so when we created the floor, we created a chain of sketch lines that are required to define the boundary of the floor. We use the sketch tools. The sketch tools, you have to change the shape of this floor. You can edit the boundary in the contextual tab, and that gives me access to all the sketch tools. These are ways to create and modify boundary lines. Boundary lines are sketch lines. And those are these purple lines that you see on the screen. And the two rules that needs to happen when you create a sketch-based object is that rule number one, all the sketch lines need to be in a closed loop. If there is a gap in the loop, you won't be able to finish the operation. And then the second rule is that sketch lines cannot intersect. So if two sketch lines are like overlapping one to another, you're going to get this angry message from Revit that you cannot finalize the operation. And once you get a closed loop and it's clean, then you just click the green checkbox and the system family will be created for you. Now, one thing I did not mention is the meaning of this double line. And if you want to access the sketch lines, again, you select the floor and hit the edit boundary tool. It's a contextual tab. And when the sketch lines is disclosed, you're going to see this double line or triple line assigned to one of the boundary edges. And this indicates the direction of the span of the floor span, the main direction. So what that means is that analytically, for structural purposes, this diaphragm, it's unidirectional. and the main direction is in the direction of these parallel lines. You can reassign it for, and this is probably, I mean, for architectural purposes, these may not matter to us, but it does matter when we do like metal pan slab type of floor slabs, because this is going to, when you create a section, for example, and you want to do this, you want to see the profile of the metal work, then you must be cognitive about what's the direction of the span. You can change the direction of the span by clicking this tool. This tool is called span direction. This allows you to pick an alternate line and define the span direction on that one. For example, if I want to change the direction, then now it's east-west direction. If I pick another one, it's north-south. And it doesn't matter which line you pick. I could pick this one, or I could pick this one. All of this is exactly the same properties, but the entire chain of line can only have one span direction. All right. So before jumping into creating the walls, you don't have to do this. I'm going to open the Mila Hyatt, the final version that is operating for 2023, just to see what we are aiming to produce. So this is a simple house, and it has an envelope of exterior walls that are made of plywood and a system of slats in the exterior. Here it is. And these walls, then the interior walls have a different profile, a different shape. Let's switch the steering line. This is what we're going to build together. And so these custom partitions display a set of internal properties that represent the internal structure of all the composite layers. This is a visual representation of the assemble from the exterior side to the interior side. You see it says exterior here, and then it says interior. And then you see a system of layers. Each layer has a numerical value, has a function, has a material, has a thickness, has a wrap property checkbox, a structural material and variable. I'm going to show you what it means. Okay, this edit assemble property, it's a property of all system family. So these dialog box, you're going to find it on walls, floors, roofs, and more recently, topo surfaces or topo solids in Revit 2024, and ceilings. All of these 5 things are the main system families in Revit. And you cannot save them as external files. And each of them can be represented using this system of layers using this similar dialog box. One of the things to point out is that Revit also keep track of mechanical and energy properties that can be associated with the assemble, including, the total thickness, which is the sum of all these values. It calculates the resistance, the R value, which is important for insulation calculation, and the thermal mass property. And all these properties are based on the material properties. So as soon as you assign a material to a layer, you're also including a set of the full R values and thermal mass values, which are used for Title 24 calculation. All right, I'm going to jump into my other project, and let's build this together. Okay, I'm gonna switch to the top view, and you can just click the top view of this navigation box. You can use these arrows to like rotate the view around its axis, vertical axis. And here on the right side, I'm just gonna build a playground of walls. I'm going to show you some of the properties of the walls, and I'm going to use some of the out-of-the-box wall types, and then we're going to create a new one from scratch. So the wall tool is under the architectural tab, wall tool. The shortcut is also WA. You can just type it on the fly. You can choose to use the ribbon icon, or you can just type WA. And when you click the wall tool, then you're presented with the type selector. Remember, this is the type selector. And remember this part of the user interface, because I name it a lot. Type selector. It gives you a list of loaded elements available to the users that belongs to the same category. So when I create a wall, I'm presenting all the wall types in the project. If I create a ceiling, I'm presented with all the ceiling types available in the project. In projects that are big and complex, this list of types is very long, and sometimes it follows naming conventions that are specific to a company. For example, you may decide on your company to name partitions in a certain way, for example, A1, 2, or B, or 0, 0, A, 3, 2, and all these partitions follow a logic that indicates what is the rating, what is the type of structural material, and then what is the type of interior or exterior finish, and whether and each company decides what's the company standard for naming walls. I'm not going to dictate here what's the best method to do that, but and obviously if you have already standards, you probably have your own standards and how the partition needs to be called. In this project, it's more descriptive, so the list of types that you see on the screen are described in words what the partition it's about. But when this list of types is really big, then you can use the type selector search tool. So the search tool is this input right below the type selector that narrow your list of options via keyword. For example, if I want to just look at where are the generic walls, then you can just type generic. And the list, all the list of walls are just now reduced and filtered to the names that match that criteria. So I have generic 5 inches, generic 6 inches, generic 8 inches, etc. This was a new feature in a couple of years ago, and it works for every type of type. Then at the bottom of this dialog box, you see this is the most recently used types. These are the wall types that Revit has learned that you use the most. And so sometimes, you know, when you build a wall, you may just want to go to the most recently used ones. And this is going to vary project to project. But list the most popular ones, the ones you use the most. Also, notice that if you scroll down this list of types, you're going to find a type of wall called curtain walls, and another one is called stack walls. I'm going to talk about curtain walls on the next class on Monday. Let me show you. Let's build a wall, and I show the properties of a wall. So I'm going to pick the generic 6 inch. The main thing to do before placing a wall is to look at the option bar. And that's something we don't do often in AutoCAD. Here we need to make decisions about how this wall is going to be constrained by. So the main thing is what level the wall belongs to. So here, when you build a wall, you'll be presented by all the levels in the project, and that's the start. The bottom part of the partition is going to be sitting on this level. And by all purposes, when you schedule a wall, then the wall will be associated with this level. The other thing is the method by which you define the height. And the height can be unconnected. Unconnected means that you can define the specific number for the height, or you can parametrically associate it with a level. So the wall will start on level 1 and can finish on level M, for example. Notice how then the value for the height, unconstrained height, becomes grayed out, no longer accessible. And so if we add new levels, then those levels will be listed in this drop-down list. I'm going to start the wall on level 1, and I'm going to finish on the roof level. Then the other property is the location line. And if you look at it, there are all these different types of location line parameters. I think I want to pull a PowerPoint to discuss what the location line is. Okay, so the location line is a vertical plane that anchors the wall to a level. And so it defines the start point and the end point of a wall. So when we create a wall, we typically start by picking the first one. Where does the wall start and where does it end? But then the vertical plane that anchors the wall to the ground, that is called the location line. By default, the location line is at the center line. But you can override that by picking either the interior face, interior finish face, or the exterior finish face. And sometimes you may want to use the exterior finish face or the interior finish face in areas of the building where you want to put a placeholder wall type while you decide what's the final assemble. For example, if you have a building that has a constrained site, and you want to make sure that that wall type does not overlap that property line, then maybe on the envelope walls are aligned to the finish phase from the schematic phase. So as you defining this, I mean, in Revit, it's a process of making decisions on what the assemble is, and in the process of defining assembles, there are a lot of exercises that happen before selecting the final material or the final assemble. And you need to hear consideration from the structural side, from cost perspective, from aesthetics design, before you make the final decision. But at a schematic design, let's say you start with a generic wall, and you use the finish phase, then if during the design development you change the wall type, then the location line is the line that remains fixed. And what it means is that the wall may grow to this direction, and the finish phase is what gonna is the plane that's going to anchor the wall to the ground. And so on constrained sites, you may want to use finish phase. Another place where you want to use finish phase is around elevators. You may want to wait for the structural engineer to tell you what's the final thickness of that elevator shaft. And then if you do interior finish phase, then it doesn't matter how the wall grows. It will grow towards the outside, and it will respect the opening of the shaft. It wouldn't overlap on top of it. And then another location line is the core phase. So the core is the portion of the wall that receives or has the structural functions that perform the structural functions of the assemble. For example, in the case of a CMU wall, the entire CMU wall it's a core, or the steel studs, that is a core, or wood studs, that's the core. And in some building types, it probably makes sense to use the core, because when it comes to dimension assembles, there are some examples in which, in particular in metal building, where it doesn't matter where the finish is. What it really matters is where the core lands. And for those technical people online, you're probably familiar with some of examples where you use that logic. And sometimes you use core face exterior or core face interior as a wall location line. So in a schematic design, you may want to use generic walls, like the ones you see on the screen. And then as the design phase progresses, then you can choose different wall types, and the changes in the thickness of the wall will be driven by the location line constraint. So this is an example where I apply the same wall type to a different location lines, and that's how the location line behaves. In the last example, on the core phase, is the core part of the wall types that remains fixed. Does that make sense? All right, long story for wall types. And so when we pick a wall type, we need to choose what the location line is. And these are all the different examples: center lines, core, finish, core face exterior, come face interior. The chain, let me show you what it is. If this chain is enabled, then I will be able to create a loop of walls. But if I disable that chain, then I'll do a segment at a time, which is kind of annoying because I need to do 2 clicks every time I create a piece. So a chain allows you to create a loop of walls. And then radius is what you use if you want to create an arc wall. And joint status, I'll go over that in a bit. All right, so let's create some walls here on the side. So the walls start on level 1 and finish at a roof level. I'm doing a generic 6 inches. And then I'm placing just below wall on our side. First point, second point. First point, second point. When you build walls, when you model walls, notice that Revit presents you with that temporary dimension. In temporary dimension, it helps you decide what's the final output of the wall length will be. You can notice that it snaps. In this particular example, it says snapping every inch. But the snap factor of the temporary dimension, it's a factor of the zoom. So notice this, if I zoom out a lot and I create a wall, notice now that my snap factor is every 6 inches. If I zoom out more, now it's every 4 feet. So depending on how detailed you want to go, you can have a snap factors of even 1/4 of an inch. You know, if I'm zooming this a lot, you see I'll have a 1/4 of an inch snap factors, an inch, and all I'm doing is I'm zooming with the mouse wheel, zooming out with the mouse wheel. That is, so you can use the value of the temporary dimension to help you arrive to the final length of the wall. You can also just tap on the. I think I have it delivered. No hay problema. Tengo una reunión ahorita. Disculpa. All right. So when you place the hey. Sorry. When you build a wall, then the temporary dimensions will help you. It's an aid to arrive to the final length. You can also just type on the fly. Like if you want a wall that is exactly a dimension that you have in mind, just click your first click and then just type on the fly, I don't know, 4 feet, 3 inches. And you just do 4 space 3. And that creates a 4'3" wall. You can also make changes on the wall after the fact. For example, you select this wall and click on the temporary dimension and make changes to that wall. The wall is going to grow in both sides at the same time. So here I am selecting these walls and I'm just making changes to the dimensions, make it 10, etc. The location line, notice that the location line is visually represented by these grip lines. So I want to, this button here, which is in the upper left side, this is the thin line. And thin lines switch off the line weight of the elements on the screen, but it's just for working purposes. Thin line does not impact the printing. So this is just to help the drafter or you, the modeler, to take look at a greater detail what's behind the lines. So if you enable thin lines, everything, the line weights just goes away. And here's the grips. So these generic wall, the location line is the finished face exterior. When I change this to the wall center line, notice that now the grip line is at the center of the wall. If I change this to finished face interior, then the wall, the grips are now in the interior side of the wall. The other property of a wall you need to know is the where the exterior side is. Now you can, I'm going to switch to floor plan level 1 and look at some of the walls that I built. In floor plan, in 3D, where we were doing earlier, you don't see this double arrow, but this double arrow indicates the exterior side of a wall. And the exterior side of the wall is the result of the direction by which you create the wall. So in Revit, the direction in which you create the walls matters. So let me tell you what that means. When I create a wall using clockwise direction, the exterior side is towards the outside. So look at this. I'm going to create a chain of walls. And if you take a look, the exterior side of the wall is towards the outside. So when I click each of these walls, the double arrow is towards the outside. And I am, using the clockwise direction. But then if I create walls in the counterclock direction, then the exterior side inverts. So it will be towards the interior. So I'm going to build a chain of walls using the counterclockwise direction. And if you notice, when I pick these walls, then the exterior side is towards the inside. And so something to keep in mind, because the interior and exterior may not have the same finish. And you want to make sure that your wall is properly placed according to the internal properties. You can flip the direction of the walls. If you click on this double arrow, it will flip the wall along its location line. So the location line remain in place. That is the plane that anchors the wall to the ground. When you click the double arrow, it will flip it using that line as a reference. Same here, I'm just flipping it. And what I was saying earlier, let's imagine that we are creating a shaft wall for an elevator that the structural engineer needs to give us the final thickness. And we say, initially that the placeholder that the architect placed for the wall is 6 inches, and we create a chain of walls. So wall, but the finish face that I want to use is the finish face interior. I want to make sure that this wall, no matter what type it is always aligned with the edge of the shaft, which is very important. And so I do finish face, and I create this shaft. And so when I click on this walls, look at the location line are towards the interior face of the wall. And so, a few weeks later, when the engineer says, hey, these walls cannot be 6 inches, they need to be 8 inches. You just select those walls and swap them to generic 8 inches or to generic masonry 8 inches. And the walls grow towards the outside, keeping the interior of the shaft intact, consistent. So there's no this overlap between the walls and the shaft. And so this is an example in which a technique you can use to make sure that there's an alignment between the wall and a constrained condition. All right, so the other thing, when you create walls and then you select them, Revit loves to create these temporary dimensions to anchor them. They just give you visual reference on how this wall relates to the immediate geometry around it. And you can use these temporary dimensions to change the relative location of the walls. For example, this shaft here. Notice that this shaft is measuring the wall from the center line. This temporary dimension is measuring the wall from the center of the wall. If you haven't done this, this is a chance you can do it. Let's do this very quickly. Just click a wall and create a rectangle. Architecture, wall. And then in the contextual tab, hit the rectangle tool, and we're going to create a wall that starts from the level 1. Level 1. So wall whose height start from level 1. The top of the wall, just that constraint. Okay. So I am on level 1, floor to level 1. I'm creating a wall with that start on level 1 to the roof level. By default, it knows. Notice that in floor plan, Revit automatically assign the wall, the base constraint to the current level. But in 3D, when we were doing it in 3D, I had to pick what level was the first one, what level was the base, and what level was the top. So let's create this rectangle here. This is a rectangle of walls. And then let's look at the temporary dimensions. So the temporary dimensions, by default, they extend to the center of a wall. But sometimes we in design, we may want to measure from the center. Sometimes we don't want to measure from the center. We want to measure from the face of the wall. And so a quick way to change the method that Revit measures with temporary dimensions is by clicking this witness line. And so if you select a wall and you see this temporary dimension, and you hit the witness line grip, you can just click it once. Then it's going to snap to the interior face of the wall. If you click it again, it's going to snap to the exterior side of the wall. And then if you click it again, it's going to do it again to the center. So click on the witness line to make sure you're measuring the wall. So if you're measuring the wall relative to your desired snapped faces. So right now I select this wall. The interior opening of this space is 6'8". I can change it now and make it 6 or 7 feet. That makes sense. You don't have to place a permanent dimension in order to make precise modeling in floor plans. So again, you select this wall. You see those temporary dimensions are by default associated with the center lines of the wall. If you want to override that, just click the witness line grip, change the witness line grip, and now you can make changes that are more precise. I'm going to return it to 6'8". There you go. Any question? All right, witness line, big thing about when modeling with precision in Revit. Okay, swapping wall types. You can select wall and swap it by anything available in the properties, in the type properties. So in this case, let's say I'm going to change this to an interior 5-inch partition wall. It's towards the middle of the options. And notice how Revit does display these all the interior properties of the partition only if the detail line is set to fine. So if I change the detail level to coarse, then the wall becomes, the representation of the wall is just 2 parallel lines. When I change this to fine, and I see the full extent of the internal assembles, internal layers of the wall. And in certain views, you may want to choose to display fine. For example, if you're doing a section or a section detail, and you want to display all the properties of the wall, then switch the view property to fine. Or if you're doing like 1/8 of an inch floor plans, maybe you don't want to display all the internal properties, and you set the view to coarse. And when you set to coarse, all the internal properties disappear, and they will be displayed like that. Whereas if I switch to fine, this is going to look very, it's not going to print very well at this scale. So I'm going to stay with fine, switch off the thin lines, and okay. So let's keep swapping wall types. We're just playing here. I'm going to do another one. I'm going to select this wall and I'm going to swap it with a more complex one. There is a wall type called exterior brick on CMU. A big, thick kind of wall. And then the one on the right, I'm just going to select the foundation 12-inch concrete. All right, so we have different type of wall types in this set of walls. Any question here? You guys okay? I'm going to save this. If anyone wants to grab the file or fall behind, just go grab it from the folder in Google Drive. What I want to show you now is the internal properties of walls. So this wall here, which is a generic wall, has a system of layers. You can access them if you click the edit type. And edit type, make sure you click the preview button in the lower left side to display a section detail of the partition. And so on the structural properties on the edit button, you have access to the assemble layers. And the generic wall only have a single layer. It has the structure core that is 6 inches. It has the assembly dialog box have all the different properties. It has a function, material, thickness, wrap, structural material, variable. Row number 1 here and row number 3. These are not materials. These are just delimiters. What that means is that these are defining these are separating what is the core from the exterior layers. And so the core is the part of the assemble that contains the structural properties of a wall. Those are the layers that have some structural performance that transfer the weight of the assemble, and everything that is structural needs to be contained within the upper core and the lower core boundaries. And so those things are delimiters. They don't render, they don't have any line, but everything that is structured goes between those layers. So the other thing is that the material of a wall, when it says by category, it means that it's inheriting the global material associated with the walls. And we're going to go over materials more in depth in a little bit. The thickness define what is the thickness of the symbol. That is 6 inches. The functions, if you click the functions, the drop down, you're going to find that there are 5 different functions. And the functions also are identified by a number in brackets. And that number is called the priority number. So it's just a relative way to give some importance to the functions. And so structural has a priority number 1. The substrate, which are the layers that support the finish, you know, like some metal stud framing on top of a CMU wall, for example, that's a substrate. Those have priority number 2. Thermal and air layers, thermal layers are usually the back insulation, or an air layer, those have priority number 3. And then finish 1 and finish 2, those can be the same or cannot be the same. Those are usually associated with the finish of a wall. And then there's also a membrane layer, which is usually paper. Membrane layers are usually do not get modeled. They are so thin that the thickness is 0, but for the purpose of resistance and thermal mass calculation, they're important. And so when we pick a membrane layer, the thickness must be 0. Okay, let's cancel this. And let's pick another type, wall type. Let's pick this one. This is the interior 5-inch partition. You can also, if you don't have that on the screen, just select a wall and then using the drop-down selector, go and pick the interior 5.5 partition, no, 5-inch partition to our, the 5-inch partition. Let's see the properties of this partition. Edit type. This is a section view of that wall. I don't know if you can tell from the projection, but there's this green line in the preview. That green line is the core layer, those the limiters, and they are represented visually by this green line. So on the structure, let's look at the properties of the wall. So at the center of the wall, we have a core, a structural core. We have a metal stud layer that is 2.5 inches. And notice that this core is a structural material. So the structural material is the material that is going to contain the analytical lines or the analytical planes for structural analysis. And so you can disable it. It is not important for architectural purposes, but if you're going to hand this over to a structural engineer, maybe they care about this. They do care about this, but structural engineers, when they model walls, they don't care about the finishes, but they do care about the core, what's the location of the analytical plane. And that's what this checkbox means. Then the wall goes from the exterior side to the interior side. So this is the exterior side of the wall, and this is the interior side of the wall. And then there's a correlation of all the layers here. So you have 2 finish, 2 priority number 5, a structural core, and then 2 layers on the interior side, and these are all the different thicknesses. The calculation of the R value and the total mass is an aggregate of all the material properties associated with these different layers. Wrapping, it's enable the layer to wrap at corner conditions. So when a layer has this checkbox that says wrap, then these rules kick in. Again, if this is enabled, these rules kick in. And what that means is that when this wall has, the easiest to understand is at ends. Maybe let me pick this. I have this on a slide here. Okay, so if you enable that checkbox that says wrap, then those 2 properties at the bottom are applied to that layer. When there's no wrapping, this is what happens. None of the layers wraps in the wall. If an interior, this is an example of the interior wrapping at the end caps. So that means that the interior layer wraps at the end. And this is the opposite. The exterior wall, the exterior layer is wrapping towards the interior. And so that's what that checkbox means. And this is what the Revit property means. At ends, exterior, interior. Exterior layers wrap towards the interior, or the interior layers wrap towards the exterior, and then you get a preview of what that looks like. In this case, because both the interior and the exterior layers are exactly the same, it doesn't matter what the behavior is here. Or if you say none, if you set this to none, the layers will not wrap around. Then the other one is this that says wrapping at inserts. And the options are exterior, interior, or both. So at insert, an insert is defined as a family that is hosted by a wall. So that's usually windows and doors. This is an example of an insert. The insert is this window. And so what happens here at the jams, if what that property means, it means that the exterior layers goes into the interior, or the interior goes into the exterior, or both. This is an example of both. Meaning that they meet at the location line. So the interior layers wrap at the cap and ends at the location line, and the exterior side wraps at the end and meet at the location line. That makes sense. These, if you set this to none, then nothing of this will happen. You know, you won't see these conditions if that is set to none. Now that behavior is only assigned to the layers that have the wrapping property enabled. So you enable this, and then these rules are applied to those layers. That makes sense? Let me know if you have any questions. Okay, and then variable, this column here, maybe it's not so evident in walls, it's not so used to walls, but it's more applicable for floors. I think I have a slide too. Yeah. So when you have assembles that slope, you can apply sloping surfaces. You can when we talk about floors, the floor that we did for the middle house is a flat floor. But you can also assign sloping factors. And so when the variables are unchecked, that means that all the layers slope consistently at the same time. And when the variable check is checked, it means that that particular layer is going to slope. And the same happens with roof and with floors. There's different ways of represent sloping surfaces and making sure that certain layers slope and certain layers do not. That's what this column means. Okay, so the heat transfer coefficient, the thermal resistance, the thermal mass, all of this, it's the aggregate result of the materials assigned to the different layers. And I'll jump into materials in any questions?
I have a quick question, Caesar. This is Urmila. So you showed, the variable checkboxes you showed were in the wall type, right?
Yeah.
Okay, because the example you showed was a floor, and I can understand roof, floors, slope, but would this be like a wall with the top part sloping or something, what would it,
Um,
or just a sloped wall that's, in 3-dimensional? It's kind of not a perpendicular, vertical wall. I'm just wondering how the variable would be in a wall. That's all.
yeah, and I haven't seen example where this happens in walls.
Okay.
I have only seen this used in slabs and in floors, slabs, and in roofs. But in
Okay.
walls, I don't think it's used because the walls doesn't have a sloping property.
That's
Um,
what. Okay.
yeah, and so I think if you enable it in walls, it's not going to do anything.
Okay. Got it.
Yeah,
Thanks.
yeah. Okay. All right. So another thing I wanted to show you is corner conditions. So when two walls of the same type connect in a corner and they share the same materials, they merge and they look like a single entity. You see how this CMU wall wraps around and it's very clean, but this is because each of the walls have exactly the same material. But when it comes to the similar walls, these complex compound walls and these CMU wall, Revit gives an educated guess on what this corner needs to look like. But this may or may not be how the wall gets built. In fact, I don't think it gets built this way. And so the way this works is, and that is the purpose of the priority number. The priority number that you see next to these next to the function, it's helps Revit give an educated guess on how the different layers are going to connect. And what that means is that the structural core, priority number 1, is going to connect to the structural wall, the structural layer of the opposite wall. Thermal layers are going to connect. Finishes are going to connect. Substrates are going to also connect. And so it gives Revit the ability to guess how the connection is going to be. I'm going to swap this. This is and notice how the core of this, this is the complex wall. This is priority number 1 structure. This is priority number 1 structure. These are the similar material. This is CMU. This is pour concrete, but they abut each other. So priority with bracket number 1, it's they abut if they are dissimilar, but they can also merge if they have the same material. So look at when I change this wall type from foundation concrete to CMU, see how the materials merge, even though this is a single layer, but the cores share the same property and therefore they merge. I'm going to undo that. There's and notice that this wall, the foundation concrete wall, doesn't have any exterior finishes or interior finishes, and therefore there's no layer to connect to, and so this is substrate 2, this is layer 3, and this is finish 5 or 4. It could be 5 or 4. And so all these layers like abut the concrete layer, the concrete wall here. But if this is not what how you construct this, you can override it using the modify corner conditions. And so under the corners, select this. I'm trying to remember the wall joints. So if you go to the modify tab, and then under the geometry panel, you have the wall joints. The wall joints will identify a corner condition. You see that big square that you see there. That is it's a visual set. It's a visual way to say here's a corner. And when you click on that, then you can change the configuration of the layer connections. And so you can have butt, meter conditions, or square off, butt conditions, when two materials abut to each other. Mirror is where when they meet at 45 degrees. And square off, I think it's very similar to butt. And then when you hit this next button, you see how Revit start changing the weight or the priority of the connection. So Revit knows that these two walls share the same, are abutting the core, but there are two ways to abut the core. Either this abut to this one, or this abut the other one. And so the wall joint helps you override what's the main, how the layers connect to each other. If I change this to meter, you see how it is? It's everything meter. Doesn't look right, right? Like you would never build a wall in a meter condition. I use meter mostly when I'm doing like woodwork or cabinetry, because you can use walls for do some cabinetry meter. And square off, I think for this purpose is very similar to the butt condition. That's how the wall joints work. Same here. So what's happening here? This is the interior partition, and it's connecting with a 12-inch concrete. So the core, which is the stud layer, is abutting the core of the structural foundation wall, and that's why they are like next to each other. But there are two ways to abut this, right? So if this is another way you want to construct this, you could again go to the modify tab, wall joints, hit on the wall, and then hit next, and you see how it overrides the value, the way which the connection works. It could be this way or it could be that way. Now, if you do not want this to connect at all, meaning you see how these two layers are like wrapping on the end cap of the foundation wall, then disallow the joint. Revit by default connect is attempting to make these connections between the walls, but there may be instances where you do not want that to happen. And so to disable a wall joint, select the wall, and then on the location grip, right click and hit disallow joint. And what that does is that allows you to create this condition. I mean, you have to drag in and out. And I have to maybe drag out this a little bit, or use the align tool to connect it, align this. And these walls are not connecting. There's not a connection happening. And these this icon that you see here. This is these allow join corner join. And that's telling you that that corner is not going to be automatically connected to anything that hits it. Does that make sense? If you want to do the opposite, I mean, you can grow it this direction, and then you have to drag this manually, or use the align tool. The align tool, it's under the modify tab. When you use the align tool, it's a way to align a surface with another surface. When you hit the align, you hit the destination. Where is the wall going? What is that you're moving? Again, where is the wall going? It's here. What is that you're moving? Where is it going here? What is you moving here? Oh, but you know, it's I have to disallow the join for this one as well. Disallow join. Now I can move it independently. So you have to disallow both ends in order to make individual alignments on each end. Any question about wall joins? Again, a lot of this is resolved at the detail level, and most likely you're going to have a plan view or a plan detail showing all these conditions. And even in the most, take Revit educated guess with caution, because nothing replaces your technical ability, right? And so no matter how many wall joints configuration you can ask Revit to do, at the end it's the judgment of the architects. And so the detail will need to clarify exactly how these layers connect. And oftentimes, you know, these educated guesses are just placeholders just to get something at a certain scale, but then the final configuration will be overridden by a very good detail, section detail, etc. Okay, so let's see any questions. Let's see what we've been doing in 3D. We've been building these all those walls on the side. You can change the wall by grabbing the grips. You can extend it, you can lower it, lower the size, and make use of the temporary dimensions to make dimensional changes. But also notice that the wall in 3D displays these grips. There's a grip at the top and there's a grip at the bottom. Those are called the offsets. This is the base offset and this is the top offset. And there is a parameter to the wall associated with those distances. The base offset right here and the top offset right here. So you can change this distance parametrically using the properties dialog box, or you can just eyeball it. When you grab those handles and push up, you're technically adding top offset. You see here, top offset value is changed. And the value can be negative or positive. You can also, if you're going to build like a pony wall, you could do it this way. Or if you're going to build a soffit, you can also align the bottom of the wall or increase the base offset to build a ceiling offset, some kind of a overhead wall. And then if you decide you want to reset the wall, you can just change this back to 0. Top offset and bottom offset. Okay, another property of a wall is that you can edit the profile. I like this, and you should as well. Edit the profile, it's a way to break the wall from the default or access the wall sketch lines. So if you select this wall, and by default it has a rectangular shape, when you edit the profile, you have access to the wall sketch lines. These sketch lines are hosted by the work plane. The work plane is the location line. And then you can start making changes. Say, for example, you want a wall with a sloping top. Then you can just grab one of these lines up. Revit is going to say, hey, you're breaking away from the rectangular shape. Are you sure you want to do this? Yes, remove the constraints. When you remove a constraint, you are telling Revit to divorce from the rectangular shape. Remove it. And now I'm just going to use the trim extent. The trim extent is a way to connect two lines in a corner condition. This is the equivalent of the fillet in AutoCAD. Connect it, and then hit the green checkbox. Now I have a wall with a sloping top. You can reset it. If you reset the profile, it will reconstrain the sketch lines to the default shape. Reset. I'm going to do that, reset profile, and it takes me back to the default one. You can be very creative about the edit profile, and we use it a lot in design development. Say, for example, you need to create a big opening in the wall. You can do that using profiles. So you edit the profile and say, I need the wall to do something like this. For some reason, you need a wall to do that shape. Then I clean the corners using the trim extent. And the rules of the sketch lines are that the loop needs to be connected and that the two lines cannot overlap. And as long as those two rules are in place, then I can keep this green checkbox. And then I have these wall there. And so when you select the wall and you see those double lines, that means that is a visual reference to the original shape. And that is going to be, when you reset the shape or reset the profile, it remove your custom changes and return it to the original shape. You can also edit the profile to do holes in the wall. So select the wall, edit the profile. I'm going to do this circle here. The circle inside the profile, and maybe I do another rectangle here. Now I have a wall with a circle and a rectangle. And again, if you select it, and you reset the profile, those custom changes will be clear out. But we use a lot of edit profile to adjust the boundaries to specific building conditions. In particular, when there are changes in the slope or openings that need to happen. Let's see what else. Let's do a curb wall. Curb walls are, you just create a wall, but then you define the radius here. Radius is 5 feet. So when you turn around the corner, it will make a curve for you. See that? So again, wall, radius 5 inches. And so every corner that I draft will have a 5 feet radius. 5 feet radius, 5 feet radius, 5 feet radius until you disable the checkbox. Then it becomes perpendicular wall, but you can always change it at any point. Radius. You can change the value, and you can say, okay, now I need one that it's 10 feet. Sometimes the math didn't work for me here, but let's do something else. I'm going to freeze this and do wall radius 10. There you go. You can also, those are radiuses built on the fly. You can also change it afterwards. So when you select the wall tool, notice that there is a tool called Fillet Arc, which is exactly like the AutoCAD Fillet. You need to select the 2 segments of a wall and then define the radius that will connect it. So for example, in this corner, I go to Fillet and say, okay, I need a radius of 2 feet between this. So I select the first one, select the second one, and create it for you. Now I need this to be 4 feet. Start this one, select that one, that's 4 feet. Then in 3D, this is 3D, they're curved walls. Curved walls cannot be edited to the profile. Check this out. When I select this curved wall, the edit profile is not available, unfortunately. You can only edit the profile of flat single surface walls. Okay, I want to talk about materials, and I know I took most of my time talking about all these properties of the wall, but that's fine. I mean, I want you to get an exposure of how walls work at a greater detail. And then we're going to do them for the Mila house. The other thing I want to show you is the materials and talk about object styles and visibility graphic overrides. In Revit, there are, remember I told you that categories are a set of properties that are common across multiple objects. And the categories, you cannot create them. They are given to you out of the box. In the first class, remember VG, visibility graphics, when you type VG on the fly, it will present you with the graphic override. This is the list of all the categories in Revit. But those are the properties that are specific to the view. Under the Manage tab, you're going to see the object styles settings available to you. Manage tab, object styles. And these are the global graphic properties of all the categories in Revit. And so this is the list of all the categories available in Revit. And you have how they print in projection, how they print in cut, the color in Revit, and in Revit is what you see, what you print. And so if something is in black, it's going to print black. If something is in color, it's going to print in color. the line pattern associated with those line weights, and then there's a material. And so, but these are global settings. Again, object styles. These are global settings. And so look at the material column, and the material column, there are some categories that have global materials defined. For example, topography, by default, it has the earth material. What that means is that by category, this is by category, every time we create a topography, it's going to have the material. Walls, for example, by category has a material called the fold wall. And so these three little buttons next to the material opens the material dialog box, which is the how you access materials in Revit. And so I want to talk about materials, and I think I'm going to close the session there. So materials in Revit have enormous importance because it defines the graphic qualities of the an assemble. It will define like the texture. In Revit it's called the fill pattern. It's not called hatch. In AutoCAD you call it hash. In Revit you call it fill pattern. So it also define the line weight of the projection line and the cut of the material in a cut condition or in a projection condition. It also, a material also defines the thermal properties for energy analysis. And you can access the material library under the Manage tab, Materials, the first button. So this is the list of materials that are part of these templates. So when we create a new project from scratch, it comes preloaded with a set of materials. And so this list of materials are the ones that were provided by the sampler. It's important that, you know, on your company, you have at the minimum the list of the most frequently used materials in your project. I mean, and the materials are used 80–90% on all the projects, you know, like concrete, gypsum board, or metal, or vinyl, etc. And so materials in Revit, these are all the materials that are built for you by the template. But every material has 5 different properties. They have identity properties, which is the metadata in a project. This is the descriptive information associated with the material. Then it has graphic properties. Oops. The graphic properties is how the material will be represented in a vector projection. So how it will be displayed in how patterns are displayed in projection and how patterns are displayed in cut condition. For example, CMU has a specific hatch in projection, and it has a specific hatch in cut pattern current condition. You also have appearance properties. Appearance are property, how the element is going to render under the rendering tool. And so it has bitmaps, JPEGs associated with the render that will display under rendering conditions, and a lot of different properties of relativity, transparency, etc. It also has physical properties, that holds mechanical information for structural calculation, and also has thermal properties that contain thermal properties for energy analysis. And so appearance, physical, and thermal are properties that are brought into Revit as assets. So you have appearance assets. An asset is a collection of properties. Material properties. And they can be graphical, like appearance. They can be physical, or they can be thermal. And what Revit does provide to you is an asset library. The asset library is the third icon from the lower left side in this dialog box. It's this guy here. And the asset browser brings the physical appearance and thermal properties into the project. And so the asset browser, it's much robust out of the box. This is a big library of materials that ships with Revit. It is installed as a separate component. So just for your information, you know, when you find installed projects, it's apps in Windows, features. When you install Revit, one thing that is installed is the material library. And when you look at the installed programs in your Windows, you have all these different material libraries. It's at different resolution. There's a low resolution, there's a medium resolution, and there's a high resolution. And there's a different library for different years of Revit. I have 22 and 23 in my machine. And this material library is not Revit specific, but it's common across all the Autodesk products. And so Revit, AutoCAD, Inventor, all of these packages use exactly the same material library, and Pretty Max. All of this software uses the same material library, and that's why when you open or when you export Revit into AutoCAD, it will preserve the material library because it's reading off the same database of materials. Material libraries can be big in size, particularly the medium resolution, see 1.5 gigabytes. And when we open this dialog box, the assets browser, we're actually looking at that piece of software that is installed as a common database of products. And so we have, this is the list of materials, asset materials. This is a read only. That's why you see this locks here. It's telling you that you can only read the appearance library, but you cannot modify, change, or add more elements to it. Then we have physical properties that also come from as assets. So in the same asset, properties, you have physical assets and thermal properties as well. And so let's look at an example of a material. I'm going to open, you can search materials here. And I'm going to, the most typical material, the gypsum board. You can filter materials by keyword in the search tool and look at the gypsum wall board. The identity data of the gypsum wallboard includes descriptive information. It's the name, the description, the class. These are all the different classes of materials that are there. And a class defines a list of properties. So each of these different classes have different appearance properties. You have product information like manufacturer, model, cost, URLs. You can also have material keynotes and material marks. This is a way to document a project using material keys. The other is a graphic tab. The graphic tab is how this material is represented in projection. What's the surface pattern? And Revit has, starting 2 years ago, it has a foreground and a background pattern. So you can have a pattern that is projected at the foreground and another pattern that is in the background. You have appearance assets, and this is the asset right here. This asset was brought from the asset library, and this has information about how the object is going to render. So there's this texture, that image that is pulled from the asset library that I just showed you, and all the additional rendering properties. In this case, it has a bump, a little texture associated with it, and it has physical and thermal properties. Okay, and so material it's everything. It plays a big role in the Revit documentation, and that's why I'm spending a lot of time explaining it. Because as we make choices on how these walls needs to be created from scratch, then we also need to be able to assign a material. And sometimes this material is not readily available for you, and you have to build it from scratch. So on the next class, I'm going to show you how to create a new custom wall, create a new wall from an existing one. We're going to duplicate this wall, and we're going to say different materials. We're going to create a new material from scratch, and we're going to place the walls in the envelope of the little house. So it's 7:15, a little past then. I'm going to save this file, and then we're going to pick it up again next Monday. Any questions, guys? Is this making sense?
Yep.
All right. So yeah, bear with me, my power users, because a lot of this is extra information that you may or may not know. And yes, I'm going slow, but I'm trying to make sure that you understand as much as possible on how walls work before we get started on the modeling exercise. So save that file. We're going to delete this in the next class. We're going to build a new wall from scratch. We're going to build a new texture from scratch. And we're going to build the envelope using the reference information on the floor plan. Okay, feel free to stay after the class is over if you have specific questions or if you want to share your screen. Or else I'll see you on Monday. All right, guys, have a good evening.
Thanks, Caesar.
Thank you.
Okay, bye-bye.
Thank you.
Hi, Caesar.
Hey, Marcus.
Hi. When are we gonna do, like, an exercise work when, or just asking that question?
A what?
Like like us doing the exercise thing.
we're going to we're gonna do exercise as a group. So
Okay.
we're all going to be doing the exercise at the same time.
Okay.
Were you asking for like exercise on your own?
Well, because I'm driving like every class. I'm driving back home, so the whole my drive is an hour,
Oh,
and so yeah, the whole discussion is I'm just listening, so I cannot access on my Revit. But so that's why I want to know if when are we gonna start doing where I'm gonna have to be in front of the computer so I can stay at work and maybe do it.
yeah. I think that next Monday is we're going to start like the heavy lifting. And so
Okay.
I discuss a lot of the why, the
Mm-hmm.
theory behind it,
Mm-hmm.
and then the next week is going to be intense on the modeling. So I would advise you to be at a computer next week.
Sure. Sure. Okay. That's all. Thank you so much.
Okay, Marcus. Have a good one.
See you next meeting. Bye bye.
Bye.